Hello everyone, and thank you for joining this week's Tech Talk. Today we're going to be discussing NX CAM and specifically how to create devices for your NX library to add to manufacturing files. Let's take a look. This is an Akuma machine that we'll take a look at, and what I'd like to do is create devices for my manufacturing file, and I just want to pull these from the library. So this is what we're actually going to create today. We're going to create devices that we can use in this manner. So if I want to put a device in pocket 5 for an actual tool holder, I can retrieve these devices. I can go to the tool holder and retrieve a tooling block, for example. And that will bring in that new tooling block and place it in the turret position. So I can move these around and place them in different places. So how do I make these devices and store them in the library? I've gone to a vendor catalog and downloaded a parasolid model of a new tooling device. This will be a radial holder. So we're going to start by creating a new file, and we'll import that in. I'll just name this Akuma radial holder. And we'll import this. Now we've got that imported. I'm going to go ahead and save this. I'm going to save this to my desktop and create a new folder that I'll dump into my library later. It's a little easier to work with on your desktop to avoid any sort of admin privileges you may have on your computer. So I'm going to start a new folder, and I'm going to name this the same thing. I'm going to name this Akuma radial holder. And we're just going to save this file that we are creating into that folder. We'll take that entire folder and dump it into the library later after we complete everything. So the first place I'm going to go into is my application tab. Under my manufacturing more drop down, I'm going to find the machine tool builder. Once I'm in the machine tool builder for this, I'm going to find my machine tool navigator, and we're going to rename this. This is the name of my device here. I'm going to again stick to that Akuma radial folder name, and I'll right click on this, and I'm going to insert a machine component onto this device. Once more, I'll stick to that name, Akuma radial holder. Select my object. And now I'm going to define the junctions. So this is going to be where this is placed. This is going to have think of this as a reference coordinate system that's going to place it onto a coordinate system onto the turret of the machine in those locations. So this is going to be what we'll call our device mount junction. This is going to be the tool mount. We're going to set that classified junction to tool mount, and we're going to specify our coordinate system. Where does this physically mount to the machine? I'm going to go ahead and hit OK to this. I'm going to refer back to our manufacturing file, and in its machine tool navigator, I'm going to expand this out to find those pockets. So in pocket 3, for example, we'll refer to this. So you see this little coordinate system here. The X coordinate, the X direction is going into the turret. The Y direction is pointing towards the spindle. So we'll use that as our reference to think of how we want to mount our holder. So I'm going to double click back into this and re-specify this coordinate system. So this coordinate system, if I want this to mount, my X is going into the turret, that's good, but my Y, I want that to face the spindle. And then on the classify component, you may need to expand this, and you're going to set this as, you're going to classify this as the device. Select OK. And now we have our device classification here. Now we're going to right click and insert a machine component into this one. this is going to be our tool holder. So when we think about this name, I'll show you what this name is physically going to be. On our manufacturing file, if we look at our machine tool view, you can see these devices all have holders inside of them. That's what you're going to physically put your cutting tools in. So this is the holder name we're going to apply on that field. So again, I'll start by inserting a machine component, and I'll give this a name. We'll simply name it radial tool holder. No need to select an object, that's already selected in our parent. And for this is going to be the junction is going to be the tool mount junction for this one. You can spell those out if you like. And then for our, we don't need a classified junction, but for our coordinate system, where does this tool mount? We're going to mount that right on the center line, right on the face and the center line of our tool holder. And our XC coordinate system is going to be essentially the tool axis. So we want that XC to go along the tool axis. And for this classified component, this is going to be we're going to set this as a static pocket. And we'll select OK to that. So now we've set up the device properly. We're going to save this file, and we're finished with this. So I'm going to close that out, and we're going to look at the library now. I created this Akuma radial holder. Inside that is the file I just created. That's this file. We're going to take the Akuma radial holder folder and put that into our library. So wherever your install location is, you may be on a network, you may be on your C drive. You're going to navigate into your mock resource, library, device, and then into the graphics folder. It's going to be placed into here. So I typically like to back up to the device folder so I can drag and drop it into the graphics folder a bit easier. So that's placed it in here, and we'll see our Akuma radial holder is here now. Now we're going to go into this ASCII folder, and we're going to add these devices into our device database. I already have this open here, but in this, I'm going to add this data into here so that it can find those devices. So sometimes it's a little easier just to copy a previous one and paste it, and then you can just alter the data. The data I'm looking for is the library reference is the unique record identifier. So that's going to be the name of the physical file. So I'll back up. I like to copy and paste. I'm going to go in the OD radial holder. I'll just long press this, copy that data, and paste it here, and then the description as well. So this number 2 identifies the device type as a tool holder, and then we'll save this. Now I'll come back, once I come back into NX, I'll start by resetting my manufacturing configuration files. Reset these. And now if I create a tool, I'll be able to go to Pocket 3, retrieve devices from library, and this is that number 2 designation on our database line. So in the tool holders, I can find the Akuma radial holder here. And that will place that Akuma radial holder into this location. We can see it in Pocket 3 is our radial holder, and inside of that has an actual tool holder. So now as we create a tool and we place it into this radial tool holder, that will place that tool directly into the device you've created. And now all of that can move from pocket to pocket if you like. If you move it to another pocket, that'll move with it. And then one last thing I want to point out is if I look inside the tool, the tool number, adjust register, and cutcom all are populated at the number 1. That's coming from this pocket number not being inherited. So on the holder itself inside the device, you can simply click this to inherited whenever you create these and bring them in. And now the tool will follow the pocket number. So now if I move this once again, the tool will change to 3. And you can do that with the pocket ID as well. You can follow that by the pocket number. I hope this is helpful for you. Think about the applications of creating fixture plates for milling machines or vise assemblies for milling machines. There's a lot of great ways to utilize this and apply it to your simulation kits. These simulation kits are things that we build, we develop through Prolim. If you'd like assistance or help or quotes on any of these items, we can develop entire machines with all of these devices added so you can seamlessly program. If there are any future topics you might be interested in, please email us and let us know, and we can make a future tech talk on that topic as well. I'd like to thank you all for joining me today. Please let us know if you have any questions. Thank you.